Let's start with some vocabulary. A relation is a set of ordered pairs. For example, in this case, S is a relation with 3 ordered pairs. 1, 2, 3. You might also know these as coordinates. In this case, we have X values of 0, 4, and 4, and we have Y values of 8, 3, and 6. So for the X values, 0, 4, and 4, 0, 4, and 4. You don't have to write 4 twice because that's redundant. This covers all possible X values. And then we have the Y values 8, 3, and 6, 8, 3, and 6. This is our map over here. And what the map does is it shows you which X values go with which Y values. So in this first ordered pair, we have 0 and 8. So we have X value of 0 maps to the Y value of 8. And then we have 4 and 3. So X value of 4 maps to a Y value of 3. However, we also have another one that has an X value of 4. So 4 also maps to 6, like that. In example 2, T is a relation with 4 ordered pairs. 1, 2, 3, and 4. The X values are 1, 3, 5, and 6. 1, 3, 5, and 6. And we have Y values of 8, 6, 6, and 3. 8, 6, 6, and 3. And then we also have them mapped. So an X value of 1 maps to a Y value of 8. 1 goes to 8. 3 goes to 6. 5 also goes to 6. So X value of 5 points at a Y value of 6. And X value of 6 maps to a Y value of 3. So these maps will help you visualize what you see when you see one of these sets. Here's some more vocabulary. A domain is a set of allowable inputs or arguments. In this case, the domain would be X, all of the X values. And the range is the set of achievable outputs or values, which are, in this case, the Y values. So in this example, with the set S, we have the 3 ordered pairs, and we have our map that shows which X values go to which Y values. And in this case, the domain would be all of the X values, and the range is all of the Y values. So here, the domain of S is 0 and 4, those 2 values, and the range is 3, 6, and 8. In our second example, we had 4 ordered pairs in T. The domain is the X values, and the range is the Y values. All right, so let's get started with some examples. Determine if each of the relations below is a function and provide an explanation to support your answer. All right, so the first thing we're going to do is draw a map of this relation. All right, so based on this map, is this a function? We can map 1 to 3, 4 to 7, and 6 to -1. So this is a function because each input maps to exactly one output. All right, next one. Here we have another set of ordered pairs or a relation. Draw the map. Here we go. There's our map. All right, so 2 maps to 4, 3 maps to 4, 5 maps to 4, and 6 maps to 4. They all point to one output. Is this a function? It is, because each input has to map to one output. So it doesn't matter that they all point to this one output, that each one of these just needs to point to one number. All right, and the final example. Here is a relation with 5 sets of ordered pairs. First, you draw your map. All right, so let's map this out. The input value of 1, oh no, it maps to 2 separate values in the outputs list. So I can tell you right away, this is not a function. Because remember, each one has to map to only one number. So if one X value here maps to 2 separate Y values, that is not a function. State the domain and range for each relation and tell whether the relation is a function. All right, the domain is 2, 3, 4. The range is 7, -3, 8, or if you want to put it in order, -3, 7, 8. Each x value maps to exactly one y value, so therefore this is a function. Here we have a domain of -5, -2, 3. They all map to one single y value, which is allowed. Therefore, and the range here is just 4. Therefore, this is a function. Here, however, we have a domain of -1 and 2, but a range of 5, 8, 9. Here you can see one x value has two different y values. Therefore, this is not a function. And here are the answers.